All right, let's pull back the curtain on the digital world. Today, we're going to follow a single piece of code on this incredible journey, starting as just an idea in a developer's head, going through a super high-speed automated factory, and finally landing right on the screen you're looking at now. This process, it's the hidden engine behind pretty much every app and website you use. So think about it. A developer writes some code for a new feature. Awesome. But there is a huge, massive gap between that code sitting on their laptop and it actually working for millions of people out in the real world. How do we bridge that gap? Well, that's exactly the question we're going to answer as we tour this modern software factory.
Here's the plan for our trip. We're going to see how the blueprint for our project gets made with a tool called Maven, then how it's stored in a shared library using Git and GitHub. We'll meet the factory foreman, Jenkins, who runs the whole show. After that, we'll see how everything gets packaged up into a universal shipping container with Docker. And finally, how we manage a whole global fleet of these containers with Kubernetes. Let's jump in.
You know, every great build starts with a blueprint. And in the software world, that means we have to take all that raw code and turn it into something structured, something we can actually build. So, our first stop is creating that essential blueprint. See, modern applications are, well, they're complicated. They're like these intricate machines made up of hundreds of different parts. If you tried to put it all together by hand, it would be total chaos. That's where Maven comes in. Its job is to be the master assembler, making sure that every single developer on the team builds the project in the exact same repeatable way every single time. No guesswork.
The whole operation is run from one central file, the pom.xml. The best way to think about this is like a recipe for your project. It lists out all the ingredients, all the external libraries and tools your code needs to work, and it also gives the step-by-step cooking instructions for how to compile, test, and package everything up just right.
And here's the cool part. A developer just types one simple command, end-the-end clean package. That's it, and that kicks off the whole assembly line. First, clean gets rid of any old junk from previous builds. Then, compile turns the human-readable Java code into code the machine can understand. Next, test runs a bunch of automated checks to make sure nothing's broken. And finally, package bundles it all up into one finished product.
And what comes out at the end of this stage? A single file, usually with a .war extension, which stands for Web Archive. You can think of this as the complete, totally self-contained application. All the code, all the images, everything, sealed in a box and ready for the next step.
Okay, so our application is packaged up. That's great. But what if a developer accidentally introduces a bug? How do we rewind time? And how do you get a whole team of people working on the same code without them all stepping on each other's toes? For that, we need a really smart library. This is where a tool called Git is absolutely essential. A Git repository is basically the project's ultimate history book. It tracks every single change. Each one of these saved changes is called a commit. Now, when a developer is ready to share their work, they push their commits up to a central remote repository. And that's where GitHub comes in. GitHub is that shared, cloud-based library where the official master copy of the code lives for the whole team to see. Now, this is the really critical part. How do we connect our library to our factory? We use something called a webhook. And honestly, the best way to think of it is as a doorbell. The second a developer pushes new code to GitHub, that webhook rings a bell over at our automation server. It's basically shouting, "Hey, we got fresh code over here. Time to start the assembly line." This is the trigger that makes the whole process automatic.
And that doorbell, it rings right here. This is the heart of the entire operation. Welcome to Jenkins, the tireless foreman of our software factory.
Jenkins is our master orchestrator. It just sits there, listening for that doorbell from GitHub. The moment it rings, Jenkins jumps into action and follows a series of steps that we've already defined. This whole pipeline gets rid of all that boring manual work that humans are, frankly, not very good at, and it guarantees that every single code change goes through the exact same quality control process. So, the Jenkins pipeline is our automated assembly line. As soon as that webhook rings, first thing Jenkins does is clone the very latest code from GitHub. Then it runs those Maven commands we just talked about to build the application. After that, it moves on to the next stages of our factory, building something called a Docker image and deploying it, which is exactly what we're going to look at next. Okay, our app is built, it's packaged, but now we have a whole new problem. How in the world do we make sure that it runs exactly the same way on some server in the cloud as it does on a developer's own laptop? Ah, yes, this phrase is a classic. I'm sure you've heard it. A developer builds something, it works perfectly on their computer, but the moment they hand it off to someone else, it just breaks. Why? Because the server environment is just a tiny bit different. This is the exact problem that Docker was invented to solve. So before containers, the solution was something called a virtual machine. A VM is like having a whole separate computer, a guest operating system running inside your main computer. It's powerful, sure, but it's also really heavy and slow to get going. Docker containers are different. A container is this super lightweight, standardized package that holds just your app and only the specific things it needs to run. It's totally isolated, it's portable, and it's fast. So how does it all work? Well, it all starts with a simple text file called a Docker file. Think of it as another recipe card. Docker reads this recipe to build a Docker image, which is like a frozen, read-only blueprint of your application and its environment. And when you actually run that image, you get a Docker container, a live, breathing instance of your app. And where do all these images live? In a place like Docker Hub, which is kind of like a giant supermarket shelf for Docker images. Okay, we've solved the "it works on my machine" problem. Our app is neatly tucked inside a standardized container. But modern apps, they aren't just one container. We're talking hundreds, sometimes thousands of them. How do you even begin to manage all of that? This right here is the challenge of scale. I mean, running one container, easy. But what happens when you need to run 10,000 of them? And you have to make sure they can all talk to each other, and you need to automatically replace any that crash, and you want to update them all with zero downtime? It sounds like chaos, right? Well, that's where our final tool comes in. Kubernetes is the orchestrator for all those containers. So if Docker gives us the standardized shipping container, then Kubernetes gives us the entire fleet of cargo ships and the global port authority to manage them. It's this massive system designed from the ground up to manage huge clusters of containers, handling all the complicated logistics for you automatically. So let's break down the basic ideas. The whole group of computers that Kubernetes manages is called a cluster. The smallest thing it can deploy is called a pod, which is just a little wrapper around one or more of our containers. Then you tell Kubernetes what you want, like, hey, I always want 3 copies of my app running, and you do that using a deployment. And finally, you make those pods available to the world with a service. So how do you talk to this giant distributed brain? You use a little command line tool called kubectl. It's your universal remote control for the entire cluster. From right there in your terminal, you can ask the cluster how your app is doing, you can tell it to scale up to handle more traffic, or you can roll out a brand new version. And this is the real magic of Kubernetes. You don't tell it how to do things. You just describe the final state that you want to exist. You write down this desired state in a special file called a YAML manifest. It's like an instruction manual. You just hand that manual to Kubernetes, and it works tirelessly, 24/7, to make sure the real world perfectly matches your instructions. So there it is. From a developer's keyboard through Maven's blueprint, GitHub's library, Jenkins's factory, Docker's shipping container, and all the way out to Kubernetes' global fleet. Our code is now live. But you see, this whole system, this incredible factory, it's not just about the technology. It's about shrinking the time it takes to get an idea out into the world from months down to minutes. So the real question is, with a factory like this at your fingertips, what will you build?